Hi, this is Mrs. Rodriguez, your algebra teacher. This video is about lesson 10-3 from your textbook. Okay, go ahead and share my screen with you. So this is all about operations with radical expressions. Okay, so let's go ahead and get started. So first talks about how you have to add or subtract radical expressions. So to add or subtract radical expressions, the radicands must be alike in the same way that monomial terms must be alike to add or subtract. So it gives this example, if you had something like 4a plus 2a, you could combine those because they're like terms, and that would be 6a. So if you had something like 4 radical 5 plus 2 radical 5, these are like radicands, okay? And you can add what's in front of the radical and then keep the radical the same. So this would be 6 radical 5. Same thing with subtraction. You would subtract what's in front of the radical symbols as long as what's under the radical is the same, okay? They have to be like radicands. All right. So let's look at an example of this. Okay, so it says to simplify each expression. So here we have 6 radical 11 plus 2 radical 11 minus 9 radical 11. Well, they all are like radicals. So I would just add or subtract what's in front. So 6 plus 2, that would be 8. And then 8 minus 9 would be -1. And then my radical would stay the same. So it'd be -1 times radical 11, which can be simplified to negative radical 11. We don't need that 1 in front of the radical symbol, okay? All right, so next example here. So here we have a couple more terms, right? So we have 4 radical 3, and we have -6 radical 3. So these are like radicands. So we can combine these or subtract 4 minus 6, which would be -2, and then our radical 3 would still remain the same, okay? Then we also have 3 radical 7 plus 3 radical 7. Now those are like radicands, so we can add what's in front of the radical, so that would be 6, and then we would keep the radical the same. So this, we cannot combine, we cannot add this -2 and the 6, we would just stop right here. So it'd be -2 radical 3 plus 6 radical 7, final answer, okay? Okay, next one. Now here, notice what's under the radical are not the same, okay? Here we have a 12 and here we have a 48. However, we can factor out a perfect square and see if we end up with like radicands, okay? So I can break down radical 12 to 4 times 3, right? 4 times 3 is 12, and 4 is a perfect square, okay? So that's why I chose those two factors. I know 6 times 2 is also 12, but 6 is not a perfect square, and neither is 2, so it doesn't make sense to use those, okay? And then -6, and then 48 has a perfect square factor of 16. So it'd be radical 16 times radical 3, because 16 times 3 is 48. So then if we simplify this, 4 times the square root of 4, which is 2, times radical 3, and then 6 times the square root of 16, which is 4, times radical 3. So I know 4 times 2 is 8 radical, and then I still have to multiply by radical 3. And then 6 times 4 is 24, and then I still have my radical 3. Well, what do you know? Now I have like radicands, right? So now I can subtract what's in front of my radical signs, and I would end up with 8 minus 24, which is -16, and then my radical, what's under my radical would stay the same. So my final answer would be -16 radical 3, okay? All right. Next example. Again, we're simplifying these expressions. So 24, we could break that down to 4 times 6, right? Now remember, 12 times 2 is also 24, but 12 or 2 is not a perfect square, but 4 is a perfect square. And then 54, 9 times 6 is 54, and 9 is a perfect square. And then 96, 16 times 6, 16 is a perfect square, okay? So then we simplify. The square root of 4 is 2 times radical 6. The square root of 9 is 3 times radical 6. And the square root of 16 is 4 times radical 6. Well, what do you know now? All of the terms have like radicands. So now we would do 2 minus 3, which is -1, and then -1 plus 4, which would be +3. And our radical is still the same, radical 6. So it's 3 times radical 6 is our final answer. Okay. So then the next section talks about multiplying radical expressions, okay, which is similar to multiplying monomials. So here when we multiplied 2 times x by 3 times x, we multiplied the coefficients, 2 times 3, and then the variables, x times x, which was x squared. So this would be 6x squared. So here, if we have radical expressions that we're multiplying, we would multiply what's in front of the radical. So here we have 2 times 3, which is 6. And then we would multiply radical x times radical x. Well, x times x is x squared, and then the square root of x is x, okay? You can also apply the distributive property to radical expressions and also use the FOIL method, okay? And we'll try both of those. All right, so here we have 2 radical 6 times 7 radical 3. So we'd multiply what's in front of the radicals. 2 times 7 is 14. And then what's underneath the radicals, 6 times 3 is 18, okay? And then 18 has a perfect square factor. So we can break down 18 to 9 times 2. Okay, the reason we chose 9, remember, it's a perfect square. So we would have 14 times the square root of 9, which is 3, times radical 2. So 14 times 3 is 42, and we would still multiply by radical 2. So that would be our final answer. Okay, next problem. Now here we're going to be using the distributive property, okay, because we have a term outside of a parentheses, okay? So we would multiply 3 times 4. Those are the terms in front of our radicals. So that would be 12. And then the radicands under 2 times 3 would be radical 6, plus 3 times 6, which is 18. And then radical 2 times radical 2 would be radical 4. So then we have 12 radical 6 plus 18 times the square root of 4, which is 2. So if we multiply 18 times 2, we get 36. And this is our final answer. We do not add the 12 and the 36 or anything like that. They're not like radicands, okay? All right, and then for this example, notice this looks very similar to when we're using the FOIL method. Okay, so you can definitely apply the FOIL method here. So we would take the first terms, radical 3 times radical 15, and we would get radical 45. And then the outer terms, radical 3 times radical 12, which would be radical 36, times the inner terms, negative radical 2 times radical 15, so that'd be negative radical 30. And then the last terms, negative radical 2 times radical 12, which would be negative radical 24, okay? So then we want to see if we can, if any of these have a perfect square factor, okay? 45 does, because 9 times 5 is 45. The square root of 36, well, 36 is a perfect square, right? 6 times 6 is 36. So we would simplify that to 6. Now, radical 30 does not have a perfect square factor, so we leave it as radical 30. And then radical 24, 4 times 6 is 24, and 4 is a perfect square. So let's clean this up by simplifying a little here. Radical 9, the square root of 9 is 3. Radical 5 plus 6 minus radical 30 minus the square root of 4, which is 2, times radical 6. Now, notice I don't have any like radicands, so this is as far as I can go, okay? That's it, okay? All right, so hopefully this video was helpful to you and it answered any questions that you had. If not, if you still had questions after watching this video, you can definitely call, text, email, or stop by my office hours, and I'd be happy to help you. All right, you have a great day.